Right now, wherever you are, something is happening that physics cannot explain, and you have never once questioned it. Time is moving forward, only forward. The coffee cooling on your desk will never gather its heat back and reheat itself. The face in your old photographs will never grow younger. And here is the part that should stop you cold. When physicists write down the deepest laws we know, the laws that govern every particle in your body, those laws do not care which way time runs. Run them backwards and they work perfectly. The universe is built on equations that have no past and no future, and yet you are trapped inside a single direction, sliding forward, unable to turn around. If that unsettles you even slightly, take a second to like this video and subscribe, because tonight we follow this thread all the way down and it goes somewhere genuinely disturbing. Tell me in the comments what time it is where you are right now, because by the end, you may not be sure that moment is what you think it is. Settle in. Turn the lights down. We're going to take time apart. Start with the way it feels, because that's where the trap is set. Time feels like a river. You are standing in it, the current at your back, and it carries you from a fixed shore called the past toward an open water called the future. Behind you, everything is settled. It happened. It cannot be changed. Ahead of you, everything is possibility, undetermined, waiting. You remember what's behind. You cannot remember what's ahead. And the whole thing moves at one steady pace, 1 second per second, whether you're bored or terrified or asleep. This is the most obvious fact of your existence. It is so obvious you have never needed to defend it. Underneath the feeling sits something even more reassuring. Cause and effect. You knock the glass, then it falls. Never the reverse. The lightning flashes, then the thunder rolls. You strike the match, then the flame appears. Every action leads somewhere, and it always leads forward. This is the scaffolding your whole life is built on. You make plans because the future hasn't happened yet. You feel regret because the past already has. You trust your memory because it points backward at events that were real. Pull that scaffolding out and there is no such thing as a decision, a consequence, or a self that persists from one moment to the next. Hold on to two small things I'm going to say now, because they will come back later and they will not be small. The first is that the equations don't agree with any of this. And the second is that the beginning of everything was strangely, suspiciously neat. Tuck those away. For most of human history, nobody thought time needed explaining. It was the stage, not the play. Then, in the 1800s, physics grew up around the steam engine, of all things, and a group of very practical people trying to build better machines stumbled into the deepest mystery in the universe. The 19th century science of steam engines, thermodynamics, plus the modern theory of statistical mechanics worked out by James Clerk Maxwell, Josiah Willard Gibbs, and Ludwig Boltzmann explained the difference statistically. What they found was a single law that seemed to know which way time flowed, when nothing else did. That law is the second law of thermodynamics, and here is the honest version of it, stripped of the jargon. In any closed system, disorder tends to increase. Physicists have a name for that disorder. They call it entropy. The entropy of a closed system tends to increase until reaching equilibrium, the maximum state of disorder. That's the whole engine of the arrow. Everything you feel about the passage of time traces back to this one relentless tendency for things to come apart. Let me make entropy something you can hold in your hand, because the word does a lot of hiding. Picture a kitchen. You crack an egg into a hot pan and it spreads and cooks. You have watched this 1,000 times. Now imagine the reverse. A fried egg on the pan, cooling, lifting itself off the metal, its yolk and white pulling back together, sealing inside a shell that reassembles around them, the whole thing leaping up into your hand, whole and raw again. Nothing in the laws of physics forbids that. Every molecule involved could, in principle, run its motion backwards. And yet you know, with total certainty, it will never happen. Not once, not in 1 trillion kitchens over 1 trillion years. Why not? Because there is only one way for that egg to be a neat, whole, raw egg, and there are a staggering number of ways for it to be a spreading, cooking mess. Order is rare. Disorder is common. That's it. That's the secret. Even though every arrangement is different, the vast majority would look very similar, a jumble, while very few would have everything neatly sorted. When you shuffle a deck, you don't get it sorted by suit, not because the sorted order is forbidden, but because it's one arrangement out of an ocean of messy ones. The universe shuffles constantly. It lands on mess because there is so much more mess to land on. Now scale that up. The shattered glass that never reassembles, the smoke that spreads through a room and never gathers back into the cigarette, the perfume that fills the air and never returns to the bottle. The second law explains why cream mixes into coffee but doesn't unmix, and why a broken thing won't spontaneously reassemble. Crucially, the second law also defines a thermodynamic arrow of time. The drive toward maximum entropy is an irreversible process in a universe governed by time-reversible physical laws. So there it is, our answer. Time flows in the direction that entropy increases. The future is simply the direction in which things are messier. The past is the direction in which they were neater. That should feel satisfying. It felt satisfying to physicists too, for a while. But sit with the question it leaves hanging, because it's the question that eats everything. If entropy always increases as we go forward, then it was always lower as we go backward. Yesterday was more ordered than today. Last year, more ordered still. Keep walking backward down that staircase. The whole history of the universe was more and more ordered the further back you go. Which means, right at the very beginning, at the birth of everything, the universe must have been in a state of almost unimaginable order. The tidiest state it would ever be in. And nobody in the 1800s or now has ever been able to say why. The man who saw this coming was named Ludwig Boltzmann, and to understand what he unleashed, you have to understand what he was up against. Ludwig Eduard Boltzmann, born the 20th of February 1844 in Vienna, was an Austrian physicist whose greatest achievements were the development of statistical mechanics and the statistical explanation of the second law of thermodynamics. Picture Vienna in the late 1800s. Gaslight and cigar smoke, a university where the great debate was whether atoms were even real. Most respected physicists thought atoms were a useful fiction, a bookkeeping trick, nothing that actually existed. Much of the physics establishment rejected Boltzmann's thesis about the reality of atoms and molecules, and he had a long-running dispute with the editor of the preeminent German physics journal of his day, who refused to let Boltzmann refer to atoms and molecules. Think about what that means. This man built the correct explanation of heat, of entropy, of the arrow of time itself, on a foundation, the atom, that his colleagues told him did not exist. He was reasoning about billions of tiny particles bouncing around in a gas, at a time when admitting particles were real could get your paper rejected. He was right, and being right cost him. His great weapon was a piece of mathematics he introduced in 1872, now called the H-theorem. In 1872, he derived the H-theorem, which established a connection between thermodynamics and mechanics. What it seemed to show was breathtaking. Starting from nothing but atoms colliding under ordinary mechanics, Boltzmann appeared to prove that a gas must move toward equilibrium, toward maximum entropy, toward disorder. He had taken the messy, one-directional behavior of the everyday world and derived it from clean, timeless rules underneath. For a moment, it looked like he had explained the arrow of time from scratch. Then, a colleague ruined everything with a single devastating observation. His name was Joseph Loschmidt, and he had been one of Boltzmann's own teachers. In 1876, he pointed at the machinery and asked a question so simple it still hasn't fully gone away. The laws Boltzmann used, the mechanics of colliding atoms, run the same forwards and backwards. So how could they possibly produce a result that only runs forward? He noted that if one reversed all the velocities of the molecules of a gas when it was in a high entropy state, the underlying time-symmetric dynamics would force the system to retrace its own history, returning to the low entropy state and invalidating the theorem. This is Loschmidt's paradox, and it is the crack at the center of everything we are doing tonight. It is the objection that it should not be possible to deduce an irreversible process from time-symmetric dynamics. This puts the time-reversal symmetry of almost all known low-level fundamental physical processes at odds with any attempt to infer from them the second law of thermodynamics. Imagine filming a break shot on a pool table, the balls scattering across the felt. Now imagine playing that film backwards, the balls rushing inward to reassemble the perfect triangle. The backwards film looks absurd, but every single collision in it obeys the exact same laws of physics as the forwards film. There is nothing in the rules of the collision that tells you which version is real. The absurdity is not in the physics, the absurdity is somewhere else. Boltzmann understood immediately what this meant, and it was worse than a technical bug. It meant his beautiful theorem could not be true as a strict law. He retreated to a subtler position, and it was the right one, but notice what he had to give up. Entropy doesn't have to increase. It's just overwhelmingly likely to, because there are so many more disordered states than ordered ones. Boltzmann did not finally claim that all phase points should behave properly, but only that by far most of them should. The arrow of time was not a law anymore, it was a bet. A very safe bet, but a bet. And here's the dead end he could not walk out of. Probability arguments are symmetric, they point both ways. If entropy is overwhelmingly likely to be higher in the future, the exact same reasoning says it should have been higher in the past too. The math doesn't know the difference between forward and backward. So when you use Boltzmann's own logic to look backward in time, it tells you yesterday should have been more disordered than today, not less. It predicts a past that never happened. Every memory you have, every fossil, every ancient photograph says the past was more ordered. The mathematics says it shouldn't have been. Something has to be inserted by hand to make the past come out right, and Boltzmann spent his last years circling that gap without ever closing it. He died on the 5th of September, 1906, on holiday with his wife and daughter at a bay near Trieste. While his wife and daughter were swimming, he hanged himself. He suffered from what we would now recognize as severe depression, and the causes were surely tangled and personal. The real cause of his suicide will never be known, but it is one of the most tragic ironies in the history of science that Boltzmann ended his life just before the existence of atoms was finally established to the satisfaction of most scientists. The reality of atoms, the thing he had staked his career on, was confirmed within a few years of his death by Einstein's work on the jittering of tiny particles. He didn't live to see it. He also didn't live to see how much darker the gap he'd found would turn out to be, because the thing he couldn't explain, the strangely ordered past, was about to be measured, and the number would be a horror. This stipulation has a name. Philosophers of physics call it the past hypothesis, a term coined by David Albert. In his book Time and Chance, Albert argued that the only concept of entropy adequate to the second law is the one given by Boltzmann, and that further, what is needed is the past hypothesis, an hypothesis about the low entropy state in which the universe was first created. Read that carefully and notice what it quietly concedes. The reason we can trust our memories, the reason the past looks fixed and real, the reason cause comes before effect, none of it comes out of the fundamental laws. All of it rests on an extra assumption we bolt onto the beginning because the universe doesn't work otherwise. This is not a fringe complaint. It is the mainstream understanding. The standard resolution, associated with Boltzmann and refined by Penrose and others, is that the arrow of time is a consequence of boundary conditions. The universe began in a state of extraordinarily low entropy, and the second law is a statistical consequence of evolving away from that improbable initial state. The laws are symmetric, the arrow is emergent, and the giants of the last century saw it and accepted it as necessary. Boltzmann, as well as many of the 20th century's greatest scientists, including Einstein, Richard Feynman, and Erwin Schrödinger, saw that this hypothesis is necessary given our mostly time-asymmetric laws. Let that reframe the whole picture for you. Every irreversible thing you have ever witnessed, ice melting, people aging, buildings crumbling, your own slow slide from childhood to now, all of it is being driven, ultimately, by the fact that the universe was born tidy. The arrow in your kitchen points forward because 14 billion years ago, the entire cosmos was in one particular, absurdly rare, low entropy state, and it has been unspooling from that condition ever since. Your sense that time flows is a downhill roll away from a beginning that was, for reasons unknown, sitting improbably high on the slope. And that word, improbably, is where this stops being philosophy and becomes a number that will not leave you alone. Because a physicist named Roger Penrose actually calculated how improbable that tidy beginning was. He did the math on the miracle we've been quietly assuming, and what he found is arguably the most extreme number ever seriously written down in science. Before I tell you the number, understand what makes it terrifying. It isn't just big. Big numbers are easy. The number of atoms in your body is big. The number of stars in the observable universe is big. This is not that kind of big. This is a number that describes how special, how finely selected, how outrageously against the odds the birth of order was. And to build it, Penrose used the most disordered object we know of, a black hole. Here's the reasoning kept human. Penrose began by assuming that the maximum entropy the universe could have is that of a black hole, which is the most disordered state we know. He calculated the entropy of a black hole using equations from general relativity and quantum mechanics. This gave him an upper bound on the possible entropy of the early universe. Think of it as measuring the size of the whole playing field, every possible way the matter and energy of a universe could be arranged, from the neatest to the most catastrophically clumped. Then he asked, within that unimaginably vast field of possibilities, how tiny is the patch that corresponds to a universe starting as orderly as ours did? The answer is 1 part in 10 to the 10 to the 123. According to Penrose, the odds of the universe starting in such a special state by chance are about 1 in 10 to the 10 to the 123, a number so enormous it dwarfs even a Googleplex. I know that phrase slides right past the ear, so let me anchor it to something your body can feel, because this is the moment the whole video turns. That is not a number with 123 zeros. It is a number that has more zeros than it would take to run out of room. Writing this number out would require more zeros than the number of subatomic particles in the observable universe. Read that again. If you tried to physically write this figure, 1 zero on each particle in the entire cosmos, every atom in every star in every galaxy we can see, you would run out of particles before you ran out of zeros. There is not enough universe to write down how unlikely the universe is. Now, an honest voice has to enter here, because this is where the genre could lie to you, and I won't. Nobody knows whether the beginning was truly random. Maybe there's a law we haven't found that forced the universe to start tidy, and then the number means nothing, because it wasn't a roll of the dice at all. Penrose himself argues that this low entropy initial state is not a random fluctuation, but rather a consequence of a deeper, yet unknown physical law. That's the reassuring half, and it's real. But sit with what it actually says. To make the number stop being terrifying, you have to invent a law nobody has ever seen, whose only job is to explain why the terrifying number didn't get us. We are so disturbed by how special the beginning was that we would rather believe in an undiscovered law than accept the odds. The dread doesn't go away, it just changes its clothes. And this is exactly the corner Boltzmann had backed himself into, decades before Penrose put a number on it. Because Boltzmann, staring at that impossible tidy past, reached for the one escape hatch a statistical thinker can reach for. If order is just a rare fluctuation, he thought, then maybe the whole ordered universe we see is one. A random, temporary dip toward order in an eternal sea of chaos, the way a struck cue ball might, once in a near eternity, scatter and then by pure chance reassemble the triangle. Boltzmann explained this low entropy condition by treating the observable universe as a natural statistical fluctuation away from equilibrium in a vastly larger universe. Given infinite time, even the most absurdly unlikely dip toward order will eventually happen. So maybe we are simply living inside one of those dips, marveling at an orderliness that is nothing more than a very large, very lucky accident. It's an elegant escape, and it opens directly onto the single most disturbing idea in all of physics. Because if order is just a fluctuation, then follow the logic where it actually leads, not where you want it to go. A fluctuation big enough to make an entire universe, with its hundreds of billions of galaxies, is astronomically less likely than a small fluctuation. And nature, if it's just rolling dice forever, will always produce the small, cheap fluctuations vastly more often than the large, expensive ones. So ask the question that Boltzmann's own escape hatch forces on you. What is the smallest, cheapest fluctuation that could produce your experience of this exact moment? You want the answer to be a whole universe. It isn't. What exactly is the smallest fluctuation that can account for your experience right now? It is not a universe, it is not a galaxy or a planet or even a body. The cheapest thing a random fluctuation can make that would have your exact thoughts, your exact memories, your exact sense of sitting here watching this is just a brain. A single brain, complete with a full set of false memories flickering into existence out of the chaos for one instant, believing it has a past, believing it has a body, believing it is watching a video, and then dissolving back into nothing. This is the Boltzmann brain, and it is not a joke, not a horror story invented for the internet. It is a serious prediction that falls straight out of real physics. According to certain multiverse and eternal inflation models, random fluctuations in empty space could occasionally produce a single self-aware brain, complete with vivid memories of a past that never happened. This hypothetical observer is called a Boltzmann brain. The name comes from tracing Boltzmann's fluctuation idea to its logical, hideous end. Let me put the horror plainly, and then let me put it inside your own skull. You are certain you have a past. You remember this morning, you remember your childhood, you remember learning to read. But a Boltzmann brain would have all of those memories too, identical, vivid, utterly convincing, and every one of them would be false. This brain has memories, duplicates of your present memories, but they are false memories. The events described in the memories never happened to this brain. There is no test you can run from the inside to tell the difference. The memory of running the test would itself just be another fluctuated memory. Every piece of evidence you could reach for to prove you're real is exactly the kind of thing a random fluctuation would fake. So here is the question, and I want you to actually feel it, not just hear it. Right now, the sensation of this moment, the sound of my voice, the memory of clicking on this video, the certainty that you existed 1 second ago. What, precisely, do you have that guarantees any of that is real, and not a single instant's worth of false memory assembling itself out of the dark? File that away, because it gets worse when the professionals get involved. For most of the 20th century, physicists filed the Boltzmann brain where you'd want to file it, as a clever objection to a dead idea, interesting but harmless. The reasoning that killed it was clean and comes from Arthur Eddington and later Richard Feynman. If everything around us were a fluctuation, then whenever we looked somewhere new, we should find fresh disorder, because a fluctuation buys the minimum order needed and no more. If we really believe that the order arose from complete disorder by a fluctuation, we must surely take the most likely fluctuation, and the most likely condition is not that the rest has also become disentangled. From the hypothesis that the world is a fluctuation, all predictions are that if we look at a part of the world we have never seen before, we will find it mixed up. But we look and look again, deeper into space, and the order keeps extending as far as our telescopes reach. So we are not a minimal fluctuation. The fluctuation idea as a story about our whole universe simply fails the test. That should have been the end. It wasn't. That comfortable feeling did not survive contact with what cosmologists learned about the actual universe at the end of the century, when the discovery that empty space carries its own restless energy reopened the question and made it sharper, more concrete, and considerably harder to wave away. The phantoms came back, and they came back with equations attached. What changed was a discovery you've probably heard of without knowing it had teeth: dark energy. In the late 1990s, astronomers found that the expansion of the universe is speeding up, driven by an energy woven into empty space itself. And that discovery quietly loaded the gun. Here's why it matters, and it's the turn that makes physicists genuinely nervous. If empty space carries its own energy and the universe keeps expanding forever, then our cosmos is heading toward a future that is cold, dark, and empty. Everything decays, the stars burn out, the black holes evaporate, and what's left is an eternity of near-empty space that behaves like a warm, faintly humming vacuum, never quite still. The problem becomes especially acute in models with a positive cosmological constant, the energy of empty space we call dark energy. An empty universe with a positive cosmological constant behaves like a thermal system with a non-zero temperature, meaning fluctuations never fully stop. In that endless quiet, over spans of time that make the current age of the universe look like nothing, fluctuations keep happening. Rare ones, vanishingly rare, but given forever, vanishingly rare becomes inevitable. And in that infinite future, brains fluctuate into existence. Not many, not often, but the future is eternal, and eternity times almost never still equals infinitely many. By 2004, physicists had taken Eddington's discovery to its logical conclusion. In an eternity of thermal fluctuations, the most abundant observers would be tiny Boltzmann brains appearing in an otherwise featureless universe. So now, count all the observers who will ever exist in the entire history of this universe, past and future. On one side, the ordinary observers, everyone who evolved the normal way in the brief window of a few billion years when stars and planets existed, a finite crowd packed into the universe's short, bright youth. On the other side, the Boltzmann brains, flickering out of the dark for the rest of eternity, endlessly. The ordinary observers are a rounding error, the flickering brains are, quite literally, almost everyone. And you are somewhere in that count. Around 2002, several cosmologists became concerned that human brains in the current universe appear far less likely than Boltzmann brains will be in the future, leading to the conclusion that humans are statistically more likely to be Boltzmann brains. Do the arithmetic on your own existence and it comes out wrong. If almost every observer with your exact experience is a momentary fluctuation, then the odds say you are one too. The safe, obvious, evolved human being you feel yourself to be is the rarest kind of observer there is. Statistically, you shouldn't be it. Now, the cosmologists who work on this do not walk around believing they are disembodied brains, but watch what they do with the conclusion, because it's stranger and smarter than simple denial. They treat it as a weapon. When a theory of the universe predicts that most observers are hallucinating flukes, they don't accept the prediction. They conclude the theory is broken. Sean Carroll frames the issue not as a prediction to be taken at face value, but as a reductio ad absurdum, a test that reveals flaws in cosmological models. If your theory of the universe predicts that most observers are disembodied brains hallucinating their entire existence, your theory has a problem. This is genuinely how the field operates now. The Boltzmann brain has become a diagnostic tool, a stress test you run against any proposed model of the cosmos. Boltzmann brains appear to be a reductio ad absurdum for present cosmological theories that allow ordinary observers in only an infinitesimally tiny fraction of spacetime, and that allow infinitely more Boltzmann brains to form from fluctuations throughout a spacetime that lasts forever. Fail the test, produce too many brains, and your theory goes in the bin. Cosmological models that produce too many Boltzmann brains are now considered suspect. The paradox has been used to constrain theories of dark energy, eternal inflation, and the cosmological constant. But here's the part that should genuinely unsettle you, the part they don't put on the poster. This isn't a problem only for exotic fringe models, it reaches into our own best current description of the universe. This is not just an abstract worry. Our current best measurements suggest that dark energy behaves very much like a cosmological constant, which means our leading model of the universe may have a Boltzmann brain problem built right into it. The standard model of cosmology, the one that fits the data beautifully, the one that predicts an eternal accelerating expansion into cold emptiness, is exactly the kind of model that, taken at face value, drowns in fluctuated brains. And the easy fix, the one clean escape, is for the universe to have an ending, a death day that arrives before the brains can pile up. The easiest way to avoid Boltzmann brains is for the universe to have a death day such that it doesn't exist long enough for sufficiently low probability fluctuations to become likely. However, our current best theories do not provide such an ending. We do not have that ending, not in our current physics. So look at the shape of the argument we've arrived at, because it's a strange and beautiful and horrible thing. It's a proof that runs on absurdity. The chain goes like this. If the universe lasts forever and keeps fluctuating, then almost every observer is a Boltzmann brain. If almost every observer is a Boltzmann brain, then you probably are one. If you probably are one, then your memories are false, including your memory of learning physics, including the very reasoning that got you here. And the theory whose conclusion destroys the reasoning that produced it cannot be trusted. So the theory must be wrong somewhere. If you are likely a Boltzmann brain, then your memory of statistical mechanics is a fluctuation, your grasp of the second law is a fluctuation, and the very chain of reasoning that led you to conclude you are probably a Boltzmann brain is one more random arrangement of particles with no particular claim on truth. Feel the vertigo in that. The theory doesn't just predict something scary, it predicts something that saws off the branch it's sitting on. If you take it seriously, it eats your ability to take anything seriously, including itself. The only sane response is to insist it must be false, which means physicists are in the peculiar position of being certain that the conclusion of their equations is wrong, without yet knowing why it's wrong or how to fix it. They know the answer can't be, you're a fluke. They just can't prove it from the inside. And the reason they can't is the same reason you couldn't run a test to check your own reality a few minutes ago. Any proof you construct is made of the very thing whose reliability is in doubt. That is the quiet terror underneath all of this. Not that you are a Boltzmann brain, almost certainly you are not. The terror is that our deepest, most successful description of the cosmos, followed honestly to its end, hands you a conclusion that dissolves you, and we do not yet have the law, the ending, the missing piece that stops it. We are standing exactly where Boltzmann stood, at the edge of a gap he could not close, except now the gap has been measured and it has a number, and the number is a horror. And staring back out of it is the possibility that the ground under every thought you have ever had was never as solid as the river of time made it feel. And we still haven't asked the oldest question of all. We've been assuming that low entropy beginning simply was, a brute fact we bolt onto the front of the universe. But something had to set it. Something had to make the cosmos start tidy, against odds with more zeros than there are particles to write them on. Whatever that something was, it is the true source of the arrow in your kitchen, the reason you remember your childhood, the reason the coffee cools, the reason you are sliding forward through this one instant and not standing still or drifting back. Pull on that thread and you find you are not asking about time at all anymore. You are asking why there is a past worth remembering. And that is a door that once opened does not close. A door like that stays open and everything cold flows through it. Because the thing hiding behind it isn't exotic. It's the most ordinary machinery in all of science, and it's built on a swindle nobody advertises. Every prediction physics has ever made about the future works the same way. You feed the equations the state of things right now, and they tell you what comes next. Weather models, planetary orbits, the decay of a radioactive atom, the collapse of a dying star. Forward in time, our laws are magnificent. They are the most accurate tools the human mind has ever produced, and they all share a secret dependency they never say out loud. They only work because someone, at the very start, quietly handed them an ordered universe for free. Turn the equations around and aim them at the past, and they break. They give you gibberish. They tell you the eggs should unbreak, the smoke should gather, yesterday should have been messier than today. Every one of your memories flatly contradicts what the fundamental laws predict about the direction you came from. So physics does something it would fail a student for doing. It stops the calculation at the beginning of time and simply declares, without derivation, without justification, without a single supporting law, that the universe started in a state of almost perfect order. Then it lets the equations run forward from that stipulated tidiness, and lo, everything comes out right. The past behaves, memory works, cause precedes effect. All of it purchased with an assumption smuggled in at the front door. This is the past hypothesis, and once you see it, you cannot unsee where the weight is resting. Everything you trust about reality, the fixedness of what already happened, the reliability of the record in your skull, the simple fact that the world makes sense backward as well as forward, none of it is earned by the laws. It is borrowed against a beginning we cannot explain. We treat the ordered start of the universe the way a bank treats a deposit that was never actually made, spending its interest across 14 billion years of physics and never once asking where the original money came from. The giants knew. Einstein knew. Feynman knew. Schrödinger knew, and every one of them accepted that this assumption had to be nailed onto the beginning by hand, because without it, the whole edifice of physics doesn't describe our world at all. They didn't hide it, they just couldn't remove it. And the reason it sits so unexamined isn't that it's unimportant, it's that it's too load-bearing to touch. Kick it out and the era of time collapses, memory becomes meaningless, and the difference between remembering and imagining evaporates. So the miracle stays, propped under everything, undiscussed at dinner parties, a silent assumption holding up the entire cathedral of modern science. And the natural question, the one that ends this piece of the story, is a question of size. Exactly how big a miracle are we talking about? How unlikely is a universe that starts this tidy? Someone actually measured it, and the measurement is the most extreme quantity ever seriously written down. His name is Roger Penrose, and he asked the question with the cold precision of a man who wins Nobel Prizes for a living. He wanted to know, of all the ways the matter and energy of a newborn universe could possibly have been arranged, from the neatest to the most violently clumped, what fraction would be as orderly as ours actually was? To find the size of the whole field of possibilities, he needed the messiest thing the universe can make, its state of maximum disorder. And the messiest thing the universe knows how to be is a black hole. So Penrose used the entropy of black holes to measure the full range of chaos available, and then asked how tiny a corner of that range holds a beginning as smooth and ordered as the one we got. The answer is 1 part in 10 to the 10 to the 123. I need you to resist the ear's instinct to let that slide past as just another big science number, because it is not comparable to any big number you have ever met. Let me try to break the abstraction with something physical and watch how the attempt fails, because the failure is the point. Count every grain of sand on every beach and every desert on Earth. That's a big number. Count every atom in your body. Bigger. Count every atom in the sun, then every atom in every star in the Milky Way, then every atom in every star in every one of the hundreds of billions of galaxies in the observable universe. You have now counted, roughly, all the ordinary matter there is to count, and you are still nowhere near. Because Penrose's number is not that count. Penrose's number is a 1 followed by so many zeros that if you try to write it down, placing a single zero on every one of those atoms, 1 zero per particle across the entire visible cosmos, you would run out of atoms before you finished writing the zeros. There is not enough universe to record how unlikely the universe is. The odds against our tidy beginning are larger than the thing whose odds we're describing. The map is bigger than the territory. That's not a number anymore, that's a wall the mind slams into. And here is the moment I want to land as gently and as terribly as I can. The most likely state for anything to be in is its most disordered state. That's the entire foundation of the second law, the reason your coffee cools and never reheats. So, if the beginning of everything had been chosen at random, the way a shuffled deck lands on chaos, it should have started as a black hole soup, formless and clumped and dead. That is what the odds demanded, that is what should have happened. Instead, the universe began smooth, low, ordered, poised at the top of a slope it has been rolling down ever since, and every galaxy, every star, every atom of you exists only because it did the one thing it had essentially no chance of doing. You are not living in a probable universe. You are living inside a configuration that, by every rule of statistics we possess, should never have come to be. Your existence rests on a coincidence with more zeros than there are particles to write them on, and when you sit with a universe that improbable, a cheaper explanation starts whispering, the same one that whispered to Boltzmann in his final years. What if the order isn't the beginning at all? What if it's just a fluke, a rare accidental dip toward tidiness in an eternity of chaos, and we happen to be sitting inside the dip, mistaking our lucky ripple for the birth of time itself? That whisper is where the floor truly gives way, because if you follow it honestly, it does not lead to a comforting universe. It leads to a version of you that never existed at all. Follow the logic and it turns on you like a trap closing. If our orderly patch of cosmos is just a random fluctuation, then nature, rolling its dice for eternity, obeys one iron rule. Cheap fluctuations happen vastly more often than expensive ones. A small dip toward order is common. A large dip toward order is astronomically rarer. And a dip large enough to build an entire universe, with its hundreds of billions of galaxies and its 14 billion years of history, is the most expensive thing the dice could ever produce. So if you're going to explain your own experience as a fluctuation, honesty forces the next question, and the next question is the one that dissolves you. What is the smallest, cheapest accident that could produce this exact moment you are having right now? Not a universe, not a galaxy, not a planet, not a body, not even a brain wired into a working nervous system with a lifetime behind it. The cheapest possible thing that could generate your precise present experience, your thoughts, your memories, your certainty that you clicked on a video and have been listening for a while, is a single brain. One brain, fluctuating out of the dark, fully formed for a single instant, packed with a complete false history it never lived, convinced it has a body it does not have and a past it never had, experiencing exactly this moment, and then coming apart back into chaos before the next instant can arrive. This is the Boltzmann brain, and I want to be very clear that this is not a campfire story. It is a prediction that falls straight out of taking fluctuation cosmology seriously, and serious physicists have spent decades unable to make it go away. The reasoning is airtight and monstrous. To assemble a real human being the ordinary way, you need the full extravagance of a low-entropy universe, billions of years of cosmic history, generations of stars living and dying to forge the carbon in your cells, a planet cooling, oceans forming, life clawing its way up from single cells across an unimaginable stretch of deep time. That entire chain is an act of almost impossible order, precisely the expensive fluctuation the dice hate to roll. To fluctuate a lone brain with your exact memories for one flickering instant costs the universe almost nothing by comparison. And in an eternity of dice rolling, the cheap outcome happens overwhelmingly more often than the expensive one. Which means, if this picture is right, the flickering false brains don't just outnumber real people, they bury them. For every genuinely evolved observer who ever lived through a real past, there will be a number of momentary hallucinating brains so vast it makes Penrose's figure look modest. And you are one observer among all of them. Do the arithmetic on your own reality, and it comes out backward. The safe, solid, embodied human being you are certain you are is the single rarest kind of observer the universe can produce. Statistically, overwhelmingly, you should be the other kind. The kind that lasts an instant. The kind whose entire life is a lie assembled from noise. Let that settle into your body, because the horror isn't abstract. You remember this morning. You remember your childhood, learning to read, the face of someone you love. A Boltzmann brain would remember all of it too, identically, vividly, with the same warm certainty you feel right now. And every last memory would be false, describing events that never happened to a person who never existed before this second. There is no test you can run from inside your own skull to tell which one you are. The act of running the test, the memory of its result, your confidence in the method, all of it is exactly the kind of thing a fluctuation would counterfeit. Every scrap of evidence you could reach for to prove you're real is precisely the evidence a hallucination would come preloaded with. So the certainty drains out of the one thing you never thought to doubt. Not the external world, yourself. The continuity between the you of 1 second ago and the you of now, the thread you assumed was unbreakable, becomes the very thing the theory says is most likely an illusion. And if you can't trust that thread, if you can't trust that you existed a moment ago and will exist a moment from now, then what exactly are you counting when you count observers? What are you weighing when you weigh probabilities? How do you even ask which kind of observer is more likely when the population you're counting stretches across an infinite future and the numbers on both sides run off into infinity? That question is not a rhetorical flourish. It is the exact wall the mathematics hits, and it has a name, and the people who study it are not sleeping well. They call it the measure problem, and it is the place where the machinery of cosmology grinds itself to a halt. The whole Boltzmann brain argument rests on comparing two infinities. On one side, the finite crowd of ordinary observers, packed into the brief, bright youth of the universe when stars and planets existed. On the other, the endless drizzle of fluctuated brains appearing in ones and twos across an eternity of cold, empty space that never quite stops humming. To say which kind of observer you probably are, you have to divide one of these populations by the other. And here the trouble becomes total, because in a universe that lasts forever, both numbers run to infinity, and infinity divided by infinity is not a number. It is a question with no answer, and the answer you get depends entirely on how you choose to count, on the order in which you add things up, on where you draw the boundaries of your tally. Change the counting scheme, and the same physics tells you either that you're almost certainly real, or that you're almost certainly a hallucination. The theory does not decide for you, it hands you a bag of infinities and no rule for how to weigh them, and cosmologists have argued for 2 decades over which rule is correct, and there is no consensus, and there may not be one buried in the physics at all. This is not a detail waiting to be cleaned up, it is a crack that runs down through the foundation of every model of an eternal universe we have. And this is where you get to watch professional physicists do something genuinely eerie. They stare at the conclusion their own best theories produce, the conclusion that most observers are hallucinating flukes, that you yourself are probably one, and they do not accept it. They use it as a blade. When a model of the cosmos predicts an ocean of Boltzmann brains, they don't conclude the universe is made of hallucinations. They conclude the model is broken and throw it out. The prediction that you are a fluke has become a stamp that marks a theory dead on arrival. Sean Carroll and others treat it exactly this way, as a reductio, an absurdity so complete that any theory generating it has thereby refuted itself. Notice what that means, because it is the strangest position science has ever been forced into. Physicists are certain that a specific prediction of their equations is false, without being able to prove it false, and without knowing which part of the physics to blame. And the reason they're certain isn't experimental, it's logical, and it is the closest thing to a genuine paradox that work in science contains. Because if the theory is right, and you probably are a Boltzmann brain, then your memory of learning physics is a fluctuation. Your grasp of the second law is a fluctuation. The entire chain of reasoning that led you to conclude you're probably a Boltzmann brain is itself just one more random arrangement of noise, with no more claim on truth than a dream. The conclusion detonates the reasoning that produced it. A theory that predicts its own observer is an accident has quietly cut its own throat, because it gives you no reason to trust the very thoughts you used to reach it. So the physicists are standing at the edge of something with two truths in their hands that cannot both be held. Our best description of the universe, followed honestly, says you are probably a hallucination. And that same conclusion, taken seriously, destroys the reasoning behind every theory that produced it, including itself. Both cannot stand. One of them has to break. Something in the foundation, something we have trusted for 100 years, is wrong in a way we have not yet found. And the only way out anyone can see is to demand that the universe not last forever after all, that it carry, buried somewhere in its future, an ending, a death, a final moment past which no brain can ever fluctuate again. Because if time itself has an edge, the infinities collapse, the paradox dissolves, and you get to be real. The trouble is, our physics does not give us that ending, not yet. And so the question stops being about the beginning of time at all and turns, slowly, coldly, to face the other direction, toward how and whether all of this is ever going to stop. The universe must die for you to live. Say it plainly, and it sounds like a threat. But before we walk toward that ending, we have to sit inside the escape attempts, because the most honest way to understand how deep a problem runs is to watch the brilliant people trying to climb out of it, and to see exactly where their ropes come up short. The first rope was called inflation, and for a while it looked like salvation. In the early 1980s, cosmologists proposed that in its first sliver of existence, the infant universe underwent a burst of expansion so violent it defies imagination, doubling and doubling again, stretching a region smaller than an atom to something vast in less time than it takes light to cross a single proton. And inflation is a triumph. It explains why the universe looks so smooth in every direction we point a telescope, why space is so flat, why the cosmic background glow is so evenly warm across the entire sky. It took several of the deepest puzzles in cosmology and dissolved them in one elegant stroke. So it was natural to hope it had dissolved the arrow of time along with them. That the smoothness inflation produced was the low entropy beginning we'd been struggling to explain. It wasn't. And the reason is worth feeling in your chest, because it's the reason every escape in this story fails the same way. To do its magic, inflation needs a starting point of its own. It needs a tiny patch of space in a very particular, very orderly configuration, a field poised and smooth and low in entropy, ready to unleash the expansion. And that starting configuration is itself wildly improbable, wildly ordered. So the puzzle didn't vanish, it just relocated. It slid backward into the instant before inflation began, and stood there waiting with the exact same face. Why was the infotan so tidy? Why such perfect order before the expansion that was supposed to explain our order? Picture a wrinkle running across a carpet that won't lie flat. You press it down at one end and it obediently disappears, and you feel a flush of triumph. Until you look at the other end and see the same wrinkle has risen there, unchanged, the exact size it always was. You didn't remove it, you moved it. Inflation is that hand pressing the carpet. It relocates the mystery of the ordered beginning to a moment even earlier and even stranger. And the ordered beginning is still there, undiminished, now hidden beneath a smoother looking layer. You can push the problem back one step. You cannot push it out of the room. So the ropes got longer and stranger. Maybe, some argued, our Big Bang isn't the only one. Maybe inflation never fully stops, and bubbles of new universe keep pinching off forever, an eternal froth of cosmoi, each one its own separate bang with its own separate history. In some of those bubbles, the beginning is chaotic, in some it's ordered, and we simply happen to live in one of the rare tidy ones, because only a tidy one could grow the stars and planets and minds needed for someone to sit and wonder about it. That's the multiverse escape, and it has a certain grandeur. Cut the odds down to nothing by making infinitely many rolls of the dice, and even a 1 in Penrose's number outcome has to happen somewhere. But the wrinkle rises again at the far end of the carpet, larger now, spread across infinity, because the multiverse, if it exists, must itself run on laws. Something governs how the bubbles form, how often, with what properties, and those governing laws, that overarching machinery, must sit in some particular state. And a machine capable of producing ordered universes is not a machine you get for free. It too is a low entropy arrangement demanding explanation. The mystery doesn't dissolve when you spread it across infinite space and infinite time. It just goes thin and cold and reaches further down than before, into whatever bedrock the multiverse is standing on. And that bedrock, wherever it is, was tidy too. The question follows you all the way down, no matter how many floors you descend, and somewhere in that endless descent, a few physicists stopped trying to explain the arrow of time and started wondering whether the arrow is even there. This is where it gets genuinely vertiginous, so hold on. Sean Carroll and Jennifer Chen proposed a picture where the universe doesn't begin at a low entropy point at all. Instead, it starts from a kind of central, timeless quantum state, an eternity with no clock in it, and from that still center, two arrows of time flow outward in opposite directions. One of them is ours. The other runs the other way, into what we would call the deep past. Its own inhabitants, if there are any, experiencing their own forward, their own memories, their own cooling coffee, all of it pointing away from us. A river that splits at its source and runs in both directions at once, and from either bank, the other looks like it's flowing backward. In this picture, there is no single moment of impossibly low entropy that has to be explained. There's a middle, and entropy rises away from it on both sides, and we're simply riding one of the two currents. It's beautiful. It's also unconfirmed speculation, and Carroll would tell you so himself. But keep listening, because the next voice goes further and quieter and stranger than anyone. His name is Julian Barber, and for decades he has argued something that sounds, at first, like a man who has spent too long alone with the equations. He argues that time does not exist, not the way you think it does. There is no flow, no river, no current carrying you forward. There is only a vast, silent landscape of possible arrangements of matter, every configuration the universe could ever be in, all of them simply existing, timelessly, side by side. What you experience as the passage of time is, in Barber's view, a kind of illusion assembled from the inside. Each configuration that contains a mind also contains, baked into that mind, the false impression of a moment just past and a moment about to come. Every instant carries its own counterfeit memory of motion, and you string these frozen instants together and call the stringing time. The way still frames on a reel, held to the light one after another, give you the illusion of something moving. These are speculations, none of them is confirmed. Not one has a shred of experimental proof behind it, and I won't pretend otherwise, because the moment I dress a guess as a fact, this whole thing collapses. But look at what they all have in common. Listen to the shape of the desperation underneath them, because the shape is the real story. Every single one of these escape attempts, the branching arrows, the timeless landscape, the two-headed river, is reaching for the same radical move. Each one is trying to survive the low entropy mystery by suggesting that time itself, the forward march you feel in your body right now, might not be a fundamental feature of reality at all, that it might be emergent, a pattern that appears only from a certain angle, only when the universe happens to be arranged into complexity, into structure, into minds. And if time is emergent, if the arrow only exists from the perspective of beings like you, made of complexity, then maybe the ordered past was never a violation of anything. Maybe it's just what the universe unavoidably looks like from the inside, when the thing doing the looking is itself a fragile little pocket of order. Maybe the low entropy of the beginning isn't a miracle at all. Maybe it's the price of admission for there being an inside to look from. That should feel like relief. For a breath, it almost is. Except it doesn't answer the question. It only marches it one floor deeper into the dark. Because now you have to ask why the universe has the particular form that lets timelessness break into flowing time in the first place. Why the still center splits into two directions instead of staying still or staying single. Why the underlying laws permit this breaking at all, and why they take the exact shape that makes minds and arrows and mornings possible. The mystery of the ordered beginning has not been solved by any of these. It has been driven down out of cosmology and into the bedrock of existence itself, into the question of why there are these laws and not some other laws, or no laws, or nothing. And here is the thing you feel more and more the deeper you dig. The beginning of time is starting to look less like a puzzle with a missing piece, and more like a door standing open onto something that has no floor. Behind that door, there seems to be a kind of choice, a selection. Out of every way a universe could have started, out of all that ocean of chaos the odds demanded, this one particular ordered configuration was somehow the one that came to be. A choice that seems to have been made, though there is no one anywhere we can point to who made it. And you are standing on the far side of that choice, alive and asking about it, only because it went the way it did. Had it gone the way the probabilities screamed it should, there would be no galaxies, no stars, no you, and therefore no question. The universe filters its own observers. Only the tidy beginnings get to be wondered about, because only the tidy beginnings produce wanderers. There's a version of that thought that's almost soothing. Of course, we find ourselves in an improbably ordered universe. We couldn't find ourselves anywhere else. A chaotic one grows no one to notice its chaos. So maybe the terror is a trick of perspective, and the impossible odds are just the sound of a survivor marveling that they survived. Almost soothing. Almost. Because that argument only explains why we, existing, look back and see order behind us. It says nothing about why order should lie ahead. And when you turn from the beginning and face the other direction, the direction the arrow actually points, the direction you are being carried right now with every second that passes, the anthropic comfort evaporates completely. Nothing about our existence requires the future to be kind. Nothing about the fact that we're here to ask promises that there will be anyone here to ask later. The same low entropy beginning that granted us this brief window of stars and warmth and minds is a beginning we are spending, every moment, irreversibly. The order that made you is a finite inheritance, and the second law is the slow, patient hand withdrawing it. So the question turns, at last, all the way around and looks down the barrel of time's arrow instead of back up it. Not why did the universe begin so strangely ordered, but where is all that order going, and what is waiting at the bottom of the slope we've been rolling down since the first instant? What does it actually mean for a universe to run out of the very thing that lets anything happen at all? That is the harder question, and its answer is colder than the impossible beginning ever was.